All right, today we're doing section 2.5. We are going to graph absolute value functions. So we've solved absolute value equations, so you have seen these before, but now we're going to have them written as functions instead of equations. Graphing absolute value functions. An absolute value function or equation is of the form y equals, the mx plus b is in absolute value bars. We could also have this plus c outside of the absolute value bars. Graphs of the absolute value functions look like angles or V's. So this is what's going in that box. The vertex of a function is a point where the function reaches its highest or lowest point. A point where it reaches its highest or lowest. In an absolute value function, the vertex is at the point negative b over m comma c. So it's an ordered pair or a point. A negative sign in front of the equation flips the graph upside down, which means that it is a reflection over the x-axis. To start off graphing these, we're going to find the vertex and make a table of values. So in order to find the vertex, we need to know the general form of the equation for these. So if you refer back up to the top of your notes, the general form was y equals the absolute value of mx plus b and the absolute value plus c. So we are going to be referring back to that. So to start this off, I want us to identify our m our b, and our c from this problem. So somebody said there's no c. There's nothing out on the end here, which means c equals 0. Okay, next let's identify our m. What's our m in this case? 3. M is what's getting multiplied to the x. In this case that is 3. So m equals 3. And our b gets added inside the absolute value bars. So ours is 12. In order to find our vertex, we are told up at the top of our notes that it is negative b over m comma c. So if we plug in all of our values here, we would have negative, our b is 12, so I'm going to put that in my numerator, over m is 3, that goes in my denominator, comma, my c is 0. So when we simplify it, we get a vertex of negative 4 comma 0. So we will plot that point, yes. So we can go ahead and plot it on our graph. Ian, can you tell me how to get to negative 4, 0 from the origin?
I honestly can't even see this graph on stuff.
Okay, but in general, how do we get to it?
You go left 4 times and then you just put the dot right
Very good. Our next step will be to make an XY table. So I'm going to erase our vertex work since we already identified that. Next, we make a table of XY values. Now, when we've picked X values before, we kind of picked them however we wanted to. And it didn't make a huge difference. But I'm going to tell you that when we do this, you're going to need to pick X values, at least one X value to the left of your vertex, and at least one X value to the right of your vertex. You can't pick them all on the same side, or you will not get the whole graph. Super, super important. Pick to the left and to the right. And I would recommend only going one number to the left and one number to the right, because the further you go out, the higher up your points are going to end up being, and that will make it harder to graph them potentially. Okay, so all of that being said, what is one number to the left of my vertex? -5. And what's one number to the right? -3. These are not the only possible values to pick. These are just the ones I would recommend you picking. Alright, so then we go to plug those in. So y equals the absolute value of 3 times -5 plus 12. I'll have to erase this in a moment to be able to graph, but you should have enough room in your margins to fit this in. -3 times 5 is -15. What is -15 plus 12? Why does it then equal +3? Wonderful. Absolute values are not negative. So when we take the absolute value of -3, we end up with +3. Did we all get all this work done so we know how we did this before I erase it? No? Okay, then take a moment and make sure you get the work copied down so that you understand how we're coming up with these answers. Next, we're going to plug -3 in to our x.
Plus 12, not 15.
Oop, you're right. Thank you. Okay. 3 times -3. -9 plus 12 is +3. The absolute value of 3 is 3. Once again, do we need more time to get this copied down? Because I need to erase all of that work so I can graph my points. Okay. Then we'll do a little erasing here. So remember, I still have my vertex. That was already plotted. Now I'm going to find the points -5, 3 and -3, 3. So for -5, 3, I'm going left 5 and then up 3, putting a point, left 5, up 3. It would help if I turned a pen on. Alright, and then for -3, 3, I go left 3, up 3, and put another point. And then I can graph that. So see how if I graph this, it's going to make a V shape. These should be straight lines coming out of here. So again, I would use a straight edge and just do one side at a time. So a V up that way. And up that way. And again, we should always have arrows on the ends here. Still, like all of your graphs, I don't want just a teeny tiny V right here, right? Like, make it big so I can see it.
What about through the middle?
So we are graphing lines here, not shapes. So we do not connect these points here. The only points on our graph would be points that fall along these two lines that make the V. So I should not see anybody connecting the two sides of their graph. It's a good point. I would not have thought of that. All right, once again, if you need to have the reminder present of our general form here, yours is just above on your notes, so you might not need to be writing it out right now, but on your homework it might help to just write this at the top of your page so that you can refer back to it. It also might help to just have that the vertex is always at the point negative B over M, comma, C. Just write it at the top of your homework so it's always there for you. All right, I am going to let you work through this one on your own a little bit, but before you start, I want us to identify M, B, and C together. So by popsicle stick, not here. Logan, what is my M?
2x.
Just the 2. So the x is separate. M is just what's being multiplied to x. So M is 2. Very good. Jacob, what is my B?
-4.
Very good. We did not see that on the first one. If we are subtracting 4 in the absolute value bars, then that means our B is a -4. Finally, Quinshawn, what is C?
0.
0 again. There's nothing being added or subtracted on the end. Okay. In order to find our vertex, we take negative B over M, comma, C. So I'm going to do that down here. Negative B, or the opposite of B. B is already negative, so a negative times a negative turns it positive. So that turns it into a positive 4 over M is a positive 2, comma, C is 0 again on this one. But we know that 4 divided by 4 simplifies to be, 4 divided by 2 simplifies to be 2. So there's our vertex, 2, comma, 0. So it does come out to be a positive 2 for our vertex. All right, then when we go to find values, we go 1 up and 1 down from our x value of our vertex. So that means I would recommend, it's not the only option, but I would recommend choosing 1 and 3 for your x values. You can choose other numbers. It's not wrong to choose other numbers as long as we get values on both the left and the right of our vertex. Otherwise you end up with just one, it looks like one straight line, and that's not the case. Okay. So if we plug in 1, what is 1 times 2?
2.
2 minus 4.
-2.
Absolute value of -2 is?
2.
Now, we might start noticing a pattern here. If we plug in 3, 3 times 2?
6.
Minus 4.
2.
Absolute value of 2?
2.
Interesting. So I'm going to plot those points, 1, 2, and 3, 2. There's nothing wrong with picking values, plotting them, and graphing them this way. Okay, we can always make an XY table. There is a little bit of a shortcut for these problems though. What does the letter M usually represent to us? Slope. And in this case, if it's a 2, I would put it over what?
1.
2 over 1. And if I look at my vertex, and I go up 2 over 1, well, that's where one of my points was. If I go up 2 over 1 again, I should still land on my line, assuming I drew my line nice and straight, which it looks like I do. Up 2 over 1. There's another one. Up 2 over 1. Okay, so we can use M as slope still, but we would then have to know to reflect any of these points onto the other side, right? So that's the weird part about it. We can get half of it using our slope. The other half we would have to reflect it over this kind of imaginary line that goes through the vertex.
So we don't have to do any of the other ones?
Okay, do we need to spend any more time on this before we go on to the next example?
No.
Okay, then we will move on for now. Let's get this one copied in. While you're copying this down, I'll write down our general equation again. Okay, what do we notice that's different about number 3? It has a negative in front of here. Does anybody remember what we wrote down that would mean in the notes? It flips it. Okay, so we should know just by looking at this problem that it should be an upside down V instead of an upright V. It should flip it over. All right, so we see that negative in front there. We want to be aware of that. This one's also different because it has a C that's not 0 this time. So let's go ahead and identify our M, B, and C again via popsicle sticks. India, what is M? This one's a little tricky compared to the ones we've done. 1, very good. So if it's just X, it's a 1X, so our M is 1. Okay, our B, Charles. 1, very good. Oh, I'm going to change my ink color. And our C, because we have one this time, Nicholas, is -2. Wonderful. Okay. So then we plug in B, M, and C up to our vertex. So we have the opposite of 1 divided by 1. What does that end up being? Positive or negative? -1, comma, C is -2. So here is our vertex. So B over M is 1 over 1. But our vertex tells us that we then take the opposite of it or make it negative. Okay. So our vertex is going to be -1, -2. So I will plot that. This time it is not on the x-axis, it's down below. -1, -2. Now I know we talked about the whole slope thing, but I'm going to still make a table of values on this one since we have other stuff going on. So if I add 1 to my x value from my vertex, where does that land me? Add 1? 0. Okay, if I subtract 1, it would land me at -2. But I like 0 more than -2 personally, so that's what I'm going to choose to plug in. So y equals negative absolute value of 0 plus 1 and absolute values -2. What is 0 plus 1? The absolute value of 1 is 1. So we have the negative sign stays out in front though. So then we end up with -1 minus 2. -3. Wonderful. Notice that I just made my table big enough to plug in one value. I did that on purpose. Oops, sorry, that's a -3. Alright, so 0, -3 is down here. And then remember what we said before, we can kind of imagine this line that would exist up and down vertical through the vertex. And I can reflect this point over that line. So if we're one space away from the line, we go one space on the other side. So we end up at -2, -3. This is a small v right now. I'll erase some of that. Okay. All right, and then we can come up with more points if we want to. I'm just going to go ahead and make my V because I can use a straight edge that makes it longer. So remember what we said when we started this problem is that our V would be upside down. And here it is, upside down. We can technically still use the idea of slope on this, but we have to know that it's getting flipped upside down by this negative out in front. Right? So our slope would be 1 over 1. We do move down 1 over 1, right? Down 1, left 1, or down 1, right 1. So technically we can still kind of use it, but we have to know that it's going upside down. So we have to move down instead of up. All right, example 4. Again, while you copy this down, I'm going to write up our general form up here. Y equals the absolute value of mx plus b plus c. We find a vertex by using negative b over m comma c. All right, we do not have a negative out in front of our bars, so we don't have to worry about flipping it. So let's work on identifying M, B, and C. Ajaya, what do you think for M? 1, very good. We've got 1x there. Keaton, what about B? Perfect, -3. And finally, Christopher, what about C? Wonderful. All right, so we go to plug this in. Negative B. And B is already negative, so that means it will turn positive. So we have positive 3 over 1, comma, C is 5. And of course we know 3 over 1 is just 3, so there is our vertex 3, comma 5. I'll go ahead and plot it. 3, up, 1, 2, 3, 4, 5. And we know our V is facing upright. Okay, there's not a negative out in front here. So on this one, instead of doing a table of values, I just want to use my slope. What's my slope? 1 over 1. So from here, I'm going to go up 1 over 1. And I can do that as many times as I want. Up 1 over 1, up 1 over 1, up 1 over 1. But this is only giving me half of my graph. So I can graph this half of it. But in order to get the other half, I need to remember there's this imaginary line that goes vertically through the vertex. And I need to reflect it over the other side to get some other points on the other side of it. Or you can think about, instead of going up 1, right 1, to go up 1, left 1. Up 1, left 1. Up 1, left 1. Okay, see how these are mirroring each other across that imaginary line that I drew in black? Okay, and then that gives us the other side of our graph. Okay, so there we go. We graphed it. It didn't take as long as it did in the beginning because we were able to use the idea of our slope.